folks, so now I'm going to talk about modeling workflow. So we've split our data. There were some headaches with how this data was fitting and performing because tidy models have a lot of work cut out for them as they are still very active in the development process. So you will have to forgive my constant irritation at them. I do believe that tidy models are a useful thing to learn. I have strong opinions that are beyond the scope of this class. So let's actually look at our data, which is like one of the big tenets in this class. So here I've plotted some descriptive histograms. Not histograms, bar charts. Where we've distinguished by spam classification as a function of lots of different variables in our data. As you can see here, there are clear distinctions to be had. For example, we can look at sent email here, that email that does not have that sent, that someone who has not sent that email to you in the past, so it's an unsolicited email, there's a big chunk of them that are spam. Versus if you have received an email from that person before, it doesn't seem to have a spam chunk and things like that. I encourage you to crawl in. Y'all know what spam is. It's a pain. And our goal is to model it to make it a little less of a pain. So yeah, here are two variables that we're going to dive into. First is from, and this is whether a message was listed as from anyone. This is usually set by default for a regular outgoing email. When it doesn't happen, it's a little weird. And as you can see in our data, in our subset of it, there are two instances where there is no from option, and they're both spam. So it's perfectly predictive. Now, is that incredibly helpful? No. Because most email, both spam and not spam, have that from function. So that's one little piece, but it's obviously not enough. And we can also look at sent email here, where spam and not spam are both represented. And a sent email is indicated whether the sender has been sent an email from this account in the last 30 days. And in the case that it is true, there seems to never be spam. So when sent is 1, there does not seem to be a case when it's not spam. Versus an unsolicited email, we have both cases. So as I've zoomed in here, I've made the font too big. Now I have made it too small. When I designed these slides, I thought this was really funny, so I included it. But here, I've included a tibble that for some particular reason I have highlighted images, even though I haven't talked about images so far. But as we can see from the descriptive statistics, similar to our plots, if we were to base our probabilities on whether an image is attached or not, we would have some false positives, false negatives. And I'm going to talk more about this in a little bit, but my point is that 5% of non-spam email have an image in it, while less than 1% of spam email have images in them. Fun fact. But obviously there's a lot of variability here. Now we're going to crawl in, and yes, we're modeling Viagra. So, or actually lack of Viagra. So what I'm doing here is plotting and modeling a logistic regression where effectively we're including everything except from, sent, email, and Viagra. And we're seeing what the estimated coefficients are combined in our binomial model. And you'll notice here that it doesn't give us a lot of stuff. And that is correct, and that is the gripe I have with tidy models. Because they're not very accessible. So here, now, okay, given this model, what we're going to do is we are going to predict we're going to make a prediction based on our model using the test data and running it through our model. So we're effectively predicting the outcome on the testing data set that we built with the training data set. So here we've predicted the probabilities as a function of, well, I already said this, and I've got this here. I realize that I'm kind of babbling, but we're modeling spam, and we are going to see if we can predict well as a function of what we have. So let's take a closer look at these predictors that so here we have two that are predicted as spam. You know what? Y'all can read the slides. My point here is that we can do some cool stuff and cross-validate. Now, and all this is built up, like, yeah, we've modeled our data. We want to know how accurate it is, and we're going to do that. And so we're going to do that with receiver operating characteristic curves, which effectively plot the relationship between true positive and false positives. As I've illustrated here, you'll notice that it has a nice curve, and it maps the relationship between sensitivity and specificity, or 1 minus specificity. And so these were originally developed for operators of military radar systems, effectively like trying to evaluate whether the blip on the radar is actually worth it, and whether the rules they used to decide if a blip was worth mentioning based on these curves. The diagonal is effectively chance here, the equal trade-off. What we want is trying to find a nice balance between sensitivity and specificity. So in order to do this, we need to see how good our model is. And one good way to evaluate performance is by estimating the area under the curve. See how accurate our models are. And it turns out from our overall model in correctly classifying spam, we are at 0.8. And 0.8 is pretty good. So next time I'm going to talk more about this. I apologize that this whole lecture is a hot mess, but this is what I'm doing. So I'll see you in a bit.